Hi, a little while ago did a video on tearing down a Lascar PanelPilotAce panel meter where we had a look at what was inside and went through a few of the capabilities of it and what the limitations are for its input and output. And one of the things that we knew about it is that it has got a 4-channel 16-bit analog to digital converter with quite a wide dynamic range of input capabilities, including 4 to 20 milliamp loop, as well as up to plus or minus 40 volts. I also gave you a short taster of a sample meter application that you could very quickly put together on it to show how you can monitor, say, a power supply with a current and voltage. Since then, Lascar have now released a beta version of an upgraded firmware and design tool for the panel meter ACE. And what I've done is I've put together a demo that shows you how to use the panel meter and actually use some of the now included advanced math function, which allows you to do multiplication, division, modulus, square root, powers, all sorts of things, too many to list right now, on the meter, and assign those to digital displays, analog gauges and things. So what I've done is I've put together this power supply application and included now a power meter that not only shows you the instantaneous power, and I think Lascar have just recently released a video that actually shows you how to do that as well, but also to show you how you can accumulate the power over time so that you can calculate things like total watt hours used, kilowatt hours, instantaneous and accumulated, and things like that. The other thing that they've also included now in this current release is the use of the RS232 interface, where you can send values out of the RS232 port on the panel pilot. Now, that sounds great and all, and I will show you at least the bit pattern coming out of the PanelPilotAce, and I will also show you how you can configure it to use it. But unfortunately, with all the computers I have in my house, not one of them has got an RS232 port on it anymore. I'm not sure why Lascar decided that the RS232 was a good idea for a brand new panel meter as the interface. Maybe it's just trying to take care of some legacy industrial interfaces or something, but it would have been nice if they had allowed the communications to go out of the USB port so that you could plug it into a PC for data logging and things like that. So I will be trying to get in touch with them to see if I can get them to include that in their software, because I think in this day and age now where you can't buy PCs with serial ports on anymore, it seems redundant to be focusing on getting the RS232 working when it's plus or minus 15 and not either a TTL version of the communications or sending it out through the USB port so that you can interface it into some more advanced electronics like a PC or an embedded Linux system or something like that. So anyway, either way, I have configured it to output data from all of the display elements that I'm collecting, and I'm going to just have to show you it on an oscilloscope to show you the data stream coming out, because unfortunately I haven't been able to find a computer to plug it into to show you. And also my oscilloscope right now, I don't have the RS232 capability enabled to decode the RS232. I didn't get that module with it, so I will have to just show you it working as just a waveform coming out of it. Anyway, without further ado, let's go have a look at the circuit and how I wired up the panel meter. I've been using the development board for it, but I'm not using the onboard sensors or anything. What I've got is I've actually got a proper 4-terminal current sensor and a power supply that I'm using to feed a 50-watt LED display. So what I'm wanting to do is show you how 4-terminal works, how you can actually configure the PanelPilotAce to simulate differential inputs. It doesn't have this natively, but you can very easily, as long as you're willing to sacrifice some of your analog inputs, to configure it in a way that will give you it, especially now that with the math functionality that's included, it's relatively simple in this kind of application to get your full differential input and compensate for cable losses and things like that. So I've included the each individual analog readings on the display as well as the equivalent differential voltages, so that you can see how it will actually correct and make up for cable losses and things. Anyway, let's get to the circuit and get started with the demo. Okay, let's just start with a quick run through what I've got as a setup. I have a power supply. It's off camera, which is my Keithley 2330G. So what it's doing is right now it's outputting about 13.5 volts or just over, and you can see that actually being displayed on here because I've got no current currently being drawn through the system. So it's showing, you know, no cable losses or anything because there's no significant current to cause any losses. The positive side of the power supply comes through to this cable, which is actually feeding into the positive side of this 50-watt LED, which is currently sitting on a heatsink. Now I've only got 2 milliamps flowing through this, and as you can see, even with just 2 milliamps, it's actually quite bright, and it's going to get a hell of a lot brighter once I start putting up to nearly 800 milliamps through it. But for now, I've just got it way down low so that we don't saturate the camera. Anyway, I've got one end of the LED connected to my meter, and I've got the other end of the meter connected, so it's directly across the LED so we can measure the voltages. Now what I've also got is a second cable, which is this one here, which actually runs down to the channel 1 analog input of the PanelPilot. The green wire here is the channel 2 input, which is effectively the low side of a differential display that I'm using, and that is going to the low side of the LED. All right. Now the ground of the PanelPilotAce, which is the common analog ground, I've actually got connected further down, so there's a lot more wires. I've got the negative return, which is this red wire, going through along numerous connections here through this 100 milliohm 4-terminal current sense resistor. It's one of the Vichy ones that they kindly sent me, and the other side of that is going through little skinny wires up to the analog input of the display for measuring the current, which is on the inner 2 terminals of the differential, of the 4-terminal resistor, and then the yellow wire out of there is going to the negative side via more little crocodile clips and various other clips up to the return for the power supply and the other end of the meter. Now what I've done is I've got my right hand panel digital multimeter here, the 1273A, measuring the supply voltage on the current, but I'm measuring it, which is where often a lot of newcomers do, from the LED to the ground terminal down this little ground cluster here, which means that if there's any high currents, the voltage drops across these wires are also going to be included in the measurement, which would offset things slightly. Now I've got as I said, 100 milliohm resistor, so we'll see how the different measurement spots will affect it, because the PanelPilotAce is measuring directly across the inner 2 terminals of the current sense resistor. The DVM on the right hand side is measuring between the output of the LED and the ground common terminal of all the other connections, so it's going to include the wiring in its measurement. So you'll see the difference when we start cranking the current up. The voltage input, though, like I said, is measured directly across the LED, and so is this panel here. Now the reason I'm doing that is because my power supply is actually including, I will read the voltages straight off the front of there to show you what that is giving out, just so we can complete the picture. Anyway, that's basically the circuit. And now if I zoom in closely to the PanelPilot, you'll see how I've wired got the display working. Now I will go through the display configuration software so that you can actually see how this thing is built and uploaded for the design. I think you'll be quite impressed with the new features that are available. Alright, this is looking directly at the PanelPilot's display now. It took me probably a couple of hours or so to put together this demonstration. And what we have here is basically analog input 0, which is reading the high side of a differential pair, is reading currently 13.4 volts. The low side, because there's no current, is now reading pretty much 0 volts because I don't have enough decimal places to show anything significant. The current input, which is reading directly across the 4-terminal resistor, is reading basically 5 millivolts on the high side and 3 millivolts on the low side. Now this is immediately telling you that even though the low side is technically connected to ground, it's got a whole bunch of wires in between it, and we've got a 3 millivolt drop between the low side of this current sense resistor and the common analog ground, which, considering we've only got 2 milliamps of current flowing through this, that's quite a significant drop. And as you can see, if we were including that, it would have actually been saying that it had 5 milliamps instead of 2 milliamps, which is over 100% inaccurate at that end of the scale. So immediately now you're seeing one of the benefits right off the bat as to why 4-terminal current measurement, especially if you want it to be accurate, is important to have. The high side is there. The power down here, before we go down to the power. So what I've got is I've got a high side analog, low side analog, and then I've got the difference of the two being shown here. So as you can see, in the voltage side of this, we're reading 13.64 because the low side is not reading anything significant. And on the current side, it's actually reading, it's fluctuating between 2 and 3 milliamps, and my power supply is actually reading a fairly steady 2 milliamps. So that's pretty accurate at the low end. Remember, the A to D converter is 16 bits, and we're using differential measurement, so we're probably going to be losing a little bit of that. The other thing I put on here is the power meter, and on the left hand side I've got the current watts, which is simply multiplying the detected voltages by the detected amps that we're reading. So that's giving us 0.03 watts right now, which is, if you do the math, you'll see that that's correct. The kilowatt hours, of course, because you're dividing by 1,000 to get kilowatts, is reading pretty much 0. And I've got an accumulator here, but because that's also with such a low value, it hasn't started accumulating anything. But the timer here is actually accumulating seconds, minutes, and hours since the panel meter was powered up. So if you want to measure how much power you've used over a certain period of time, so watt hours and things, you can just hit this button and reset it. And now it'll start, as you accumulate, because this here is going to measure your kilowatt hours consumed, or your watt hours anyway. So if I put in, say, 10 watts of load on here, then after an hour, this accumulated watt hour should say 10.00 as well. All right, and obviously if you're trying to determine things like battery consumption or something like that, being able to accumulate those values is quite important as far as one of your metrics that you would use to characterize your system. Now, the other thing that I've got happening here, which you can't see down here, but which you can see if I take you up to my oscilloscope display, is that's a live feed of the RS232 output. It's set to 5 volt per division, so we basically got about 12 volts coming out here. Now, as I said, I haven't got anything that's going to actually allow me to show you the RS232 coming out, so all I can do is show you the fact that there is this data stream that it is sending out the RS232 port, and it includes every one of the analog main values that we have on the PanelPilot. So it's sending out the 13.64, the 002, the current watts, and the accumulated watts. It's not sending the elapsed time yet. That's just, I'll show you how we can actually add that into it when we go look at the software. Anyway, what I'm going to do now is I'm going to start cranking up the power on my power supply, so that we can get extra value out of this and see how it will automatically catch up and start accumulating current. So I'm just going to increase the current limit right now. So that's 100 milliamps I have it set to. It's 100 milliamps now anyway. And what I've got, as you can see, is the amps now. You've got a high side here of 235 millivolts. Now that normally would indicate 235 milliamps as well, but of course that's not what I have. My power supply is telling me I have exactly 100 milliamps. But because I'm measuring differentially, I'm able to compensate for the voltage drops across the cables, and I have 135 millivolts already dropped across my cabling between the negative side of the power supply input and the point of measure. So that's allowing me now with this PanelPilotAce to very accurately, as you can see, it's just fluctuating a little bit around 100 milliamps, but it's pretty much reading spot on. And my voltages now, if I just bring this one back up, excuse the noise. All right, I have got 15.32 volts directly across the LED, and I've got 15.376 volts up on the output of the power supply. So you can see that there's also some extra voltages being dropped around the place. Now obviously 100 millivolts of that is in the current shunt resistor sensing. So anyway, let's just start cranking this up a little further. Let's go up to about 0.5 amp. This is getting rather bright. Let me just make sure you're able to see things okay. Yep, I'm getting a bit blinded by the light here, so I'm just going to cover the LED a little bit so that I can see what I'm doing. All right, so we have 500 milliamps now. My power supply is reading exactly 500 milliamps, and my power supply is also telling me I'm outputting at its end 17.63 volts. So I've got 17.4 across the LED, but I've got 17.6 on the high side. Now obviously there's some volts drop between the power supply and the high side of the measurement, but I've also got nearly 200 millivolts now dropped on the low side, all right, from where I'm actually measuring that. And on the current side, you can see I've now got 1.78 volts on the high side, and I've got 670 millivolts on the low side. So now I've got over a half a volt dropped in wiring. So you can imagine if I was actually measuring directly across the outside, the outside of the current shunt, I would be measuring way too high. All right, nearly 1.1 amps is what I would have been thinking that I had going through this thing. But what I really have is 500 milliamps, which is what this is still showing, because the low side is being compensated for in the readings. All right, now as you can also see down here, the current wattage is 8.69 watts. The current watt hours, of course, is 8.7 because it's just rounding it off and it's divided by 1,000. And you can see here that I'm now accumulating watts. So this is just slowly incrementing over time. So if you were trying to do some profiling, and if your load was varying somewhat, you would be able to get the aggregation. Now what I've also got in here is this reset button. If I touch that, it's going to reset the accumulator and the accumulated time to 0 again, so that we can actually do a time cycle if you want to. I don't have it set or anything like that in programs yet so that it automatically stops accumulating after a period of time. You could actually do this. This PanelPilotAce now, with the additional math functionality, you would be able to, I think, set a duration for a test and have it automatically turn off the test after a certain period of time or something, or after a certain amount of power has been drawn out of a battery or whatever you might want to do, because you're able to do some advanced logic functionality and comparisons and various other math features that would allow you to set some kind of threshold or alarm, which would allow you to take other actions. Anyway, I'm not sure what else I can show you on here right now, except to, you know, just bump it up a little bit further maybe. We'll go up to about 800 milliamps. So this is now, the LED is a 50 watt LED, so I'm only driving the red channel at the moment. So it's basically about 15 watts per LED chain. Not quite 20, but about 15 is what you should be able to handle. So I'm pretty close to it there now. And as you can see on my low side, I've got a whole volt, just over a volt now, dropped on the wiring. And I've got 1.89 volts, so it's still compensating differentially for that and telling me that I've got 803 milliamps drawing, and on my power supply it's saying 800, so it's still within fractions of a percent. Now my current sense resistor is only a 1% accuracy, so you know, you can forgive it for being slightly out. And my voltage, as you can see, I'm dropping 300 millivolts now on the low side for the voltage measurements compared to the high, so now I'm reading more accurately what is being dropped across the LED for this current, which is the 18.2 volts rather than 18.6, which is what the power supply says that I'm drawing. Anyway, so that's what this is doing for us right now, and I think you'll agree that it's quite impressive compared to the earlier version of the software if you've ever had a look at it. And it's relatively straightforward to be able to configure this and do the mathematics and get it to output these through the serial port. Let's head over to the computer now and look at the software and configuration that I'd done to upload to the PanelPilotAce to actually achieve this. So first things first, if you go to www.panelpilot.com, click on downloads and download the new PanelPilotAce beta software. If you want to be able to do the advanced math and the serial, then you do need to download the beta software, alright? And you can get that quite easily, as I said, panelpilot.com, and go to downloads and scroll down to see the beta, and you can download it right to your PC. It's free. It's got, as you've seen before, it's got an emulator built in. In this case, we're actually going to be using it directly with the PanelPilot itself, and as you've already seen in the demo, we're going to hook it up to some real analog inputs and see what happens with the real system. Anyway, so download. I've already downloaded and installed it, so I'm not going to waste your time showing you how to do that. But let's just fire up the PanelPilot software now. So when you open it up, I have the project already saved. All right, now the first thing you'll have to do, if you have not already, if you haven't uploaded this and updated the firmware on your PanelPilot, is you will have to upload the firmware. So let me just grab I've got two displays, so one I haven't upgraded yet. I'm just going to show you what is involved for that. Okay, so I just connected my PanelPilot up to the computer. Now one of the things I've noticed with this beta software is when you connect PanelPilot after you've loaded the software, it doesn't pick up on it. So if you just exit the software and go right back in again, you'll see that it'll actually detect my PanelPilot up in the top right hand corner here quite happily, and now all we've got to do is start using it. So if I load my application now, alright, now irrespective of that, if you haven't updated the firmware, you won't be able to take advantage of these new math functions. So the first thing you need to do is go in here and you need to click on Upgrade Device Software. Now when you download the PanelPilotAce beta, you will get this file, sgd43a1.1.0.2277.ppsw. You need to select that file, and you can now upgrade your PanelPilot to the latest firmware. Now remember, this is beta, so there may be a few issues with it. And some of those we will discuss as we go through this demonstration. There's a few quirks in the mathematics functionality that the Lascar is saying that they will have fixed before the software is actually fully released. But for the moment, you need to compensate for certain aspects. And the main one is to do with floating point output, where after the maths, it always defaults to about 4 decimal places of output, even if you set it to 0, so it can mess up your display a little bit. But there is an easy way of compensating for that, and we'll show you what it is. Alright, so that's now finished uploading the software to my PanelPilot, and what it also does when you upload the new firmware is it will completely reset it to the default little needle 90-degree bar graph and rotating analog meter kind of display that was on it when you first got your... Alright, so let's just start with the right hand panel. If you've been using the design tools at all in the past, you will be familiar with the fact that you've got these three areas. You've got your hardware inputs and outputs, you've got your functions that leverage the hardware, and you've got your visual elements which are linked to the functional elements. So it's kind of like a tree where the data flows from its raw format, goes through logic and various other functionality before it's finally put up on a display. Or if you're inputting things like a button, then it's sort of flowing the other direction. But either way, you know, you're going through these three levels of abstraction from the hardware to your display. The elements that are new, if we look on this right hand side here, right, the meter, I haven't noticed anything that's new in the actual default meters. Maybe once they finally release it, there may be. Nothing new in the visual aspects. It's just still your basic elements. Now in your function libraries though, there are now additional items, and the first three that you're obviously going to see are the action RS232. So errors, receiving, and sending. These are the three things that you've got here that are new to previous aspects. I think there is also some differences with the actions, and the one we're going to use extensively in here is actually the action rule set, as you'll see when we go to have a look at that and configure it in a little while. The next thing of note that I've used for this demonstration, I mean there's a lot of other things that I think are in here, but is the mathematics builder, and we'll go through having a look at how that works in a moment. You need to use this if you're going to do differential inputs or simulated differential inputs, and also if you're going to be calculating things like power from two other analog inputs and things. Now we're down into some more new functionality. So you've got RS232 receive and RS232 send, which are used to receive and send from the RS232 port. They're not the hardware one. These are actually ones where you can set up functionality to respond to input from the serial port or output to the serial port, certain data that you may have in variables. String converter is another one which is new, and you will see that this is very handy for compensating for some of the bugs that are currently in this beta software. And at the bottom here, the new one that you'll see is the serial COM port. The analog in and out, digital in and out, and PWM were there before. All right. So okay, so that's a quick scan down of what's new on the left-hand column in the library. So what are we doing here? So for our display demonstration, what we've done is I've created two analog inputs, an analog input high and low, and a volt in high and low. These correspond to the differential voltage detection and the differential current detection, the current one being connected across the current sense resistor, the 4-terminal current sense resistor. The other one we've got here is the serial port. All right, so if we just go down these and look at the configuration, you'll see that the amp input high is on channel 3, the amp input low is on channel 4. I've set it from a 0 to half a volt input because I've actually got the current sense resistor set on a low side, and as we've discussed when we went through the teardown, the PanelPilotAce analog inputs has a really nice effectively a prescaler that can either amplify or divide the input voltages to the A to D converter before it gets fed to the actual converter. So I could have set this to have a 0 to 30 volt range, but what would have happened there is it would have set the an attenuator instead of an amplification on the input, and I would have lost a little bit of resolution at the low end. And because I'm using this as a low side current sense input, I know that I'm not really going to get above about a half a volt, because that would be basically 5 amps going through the current sense resistor, and the loads that I was putting on in the video before were only going up to about 1 amp. So 5 amp range is more than enough. The volts high and low, I've effectively set that to 30 volts because that's the maximum limit of my power supply, so I know that I wouldn't be exceeding that. And the COM port, this is one of the new ones. You can see here, you give it a name, which is I've just left it as a default for serial COM port. You've got the choice of native or terminal, and the baud rate, you've got quite a range of baud rate, right from 1200 baud, you can't go lower than 1200, up to 115 K2. If you're outputting a lot of data and you want to do it on a fairly quick basis, then obviously you're going to need to have the higher rating set. The rest of the configuration I left in its default mode, which is no parity, 1 stop bit, no flow control. Terminal mode, I would imagine that's for incoming data, and I haven't got anything to input data on here. Like I said, no serial ports in any of my computers anymore. The send terminator that would be sent at the end of each stream of data, carriage return line feed. Receiving, it will detect a carriage return. Basically, it will ignore the line feed because that's more compatible with a lot of systems. And the separator for parameters, that currently it's set for space, but I mean I don't care about that right now because I'm not actually receiving any data, I'm only sending it. So let's move on to the next section. Let's just, while we're on the subject of the serial port, what I have here is one item which is called RS232 Send, and what this is it is a very similar component to the action rule object. So there's this one, action set rule. When you look at the two of them, you'll see that there's a lot of similarities. And what this one allows us to do, if I go into the configuration here, you'll see over here it's got a list of actions that are going to occur when I invoke RS232 Send. Now if you click the create value list, it will pop up a screen that allows you to get a much better view of what's going on. And this is where you actually define what you're going to send out. So the pre-message is where you can set some hard coded text. So I'm saying V equals, C equals, W equals, and T equals, which is the V for volts, C for current, W for the watts, and T for the total watts for the accumulator that I showed you on the display. The second part is what you're actually going to send, and you can select a variable, a property, a fixed number, a Boolean value, string types, byte values, and color values. So you can pick all sorts of different things to output. And in my case, this one I'm sending is a property, and the property that I've got selected here right now is the volts display high value, which is part of the differential pair. And the property of that element is the text output. Right? So I'm actually sending the text of the volts high, and then I'm separating this with a comma in between this and the next line. Then I'm sending the current, I'm sending the volts display difference, not the high. My mistake there. And sending the text for that. Then if the current, I'm sending the current difference value and the text of it. For the watts, I'm sending the watts displayed value with the text element of that component. And then the totalizer, I'm sending the watts total displayed value and text. Now what I haven't done so far is sent the accumulator, and what I said to you is I was going to show you how you would just simply be able to modify this for additional parameters. And all you do is, if you want to add extra to the command lines, first of all I want to separate it with another comma. You just hit the plus symbol, and what I'm going to hit type here is A for accumulated. I know I could have used A for amp, so I've used C for current instead. And I will tell it that I'm going to use a property, and the property that I'm going to select will be the watts total displayed, which is the accumulated value. I think. No, I want to send time here. Sorry, I'm already sending the accumulated watts. So I've got this extra value of the time. Let's say S for seconds, because I have a master property with S, which is just incrementing the seconds. The display is actually using the math functions to divide it up into hours, minutes, and seconds. So let me just reselect this, and we'll use the variable this time, and we'll say accumulated time, which is a seconds counter. We won't finish that, and then that's the end of it, and we just hit save. Now I've actually added an extra output to go out with the serial port, and you can actually see this working in the emulator, so I will show you that in a moment. The next item that I've added here that's relevant to the RS232 Send is a simple timer, and I've said every 1 second continuously invoke the RS232 Send. And the RS232 Send is what we just defined, where we output the volts, the current, the watts, the total watts, and the seconds. So basically, once the application starts, it's going to send continuously every second all of those parameters out on the serial port. So that's a nice new feature that they've added. But as I said before, who has a serial port these days? I can't find one, and I've got probably a dozen computers in my house, and none of them have an RS232 port. So sorry, but I can't show you it fully working. You just have to take my word for it that it's outputting it. I showed you on the oscilloscope, but that's all I can do. I cannot at the moment test input. I'll try and get an adapter, USB to serial. The one I have is an old unsupported FTDI chip now, so I'm going to have to get a new one. Once I do that, I'll be able to enhance the demonstration to include it, but for now, sorry. Okay, next feature we're going to look at is the math builder. All of the other features of basic display and things like that I've shown you on previous videos briefly, and there's lots of demos already up on, or at least a few demos already up on YouTube that shows you how to use this. And what I want to actually show you is more of the advanced feature, how I implemented this power and also the differential inputs. So let's start with the differential inputs, because they all basically build up on each other. So I have this input here, which is my volts displayed differential. All right, that's the name of it, and it's actually fed by a math function, or indirectly. So what I have here in the middle for the function elements is, if I could just find it, I've got quite a few here, is volts differential. Now I just clicked on it here, and on the right hand side here now you can see the builder for this. I'm not sure how big I can make that. No, not very. I think I just, yeah, I'll leave that there for now. See if I can zoom in a little bit and make it bigger for you. Okay, that'll work. So you can actually expand this down. So what you do with a math builder is you, if I just clear this out, let me just try and remember what I've got here, is I've got volts digital high and volts digital low, and they're subtracting, and so I've named this volts differential. So if I just clear this out completely, and I'll just rebuild it from scratch. So when you actually double click on the math builder, you'll get an item like this on the right hand side, and it's got nothing in it. And like the other logic builders that you've seen that have already been there from the beginning with the software, you start to build functions here. So I've just clicked an item, and in this case I want an element which is the volts input high. So we go down here and we've got volts digital high, and then what I want to do to create this as a differential is add another element and tell it that that's a subtraction, add a third element, and simply say this is an element volts input low, right? Volts digital low, and that's pretty much it. Now one of the things I haven't done yet is you've also got to select the property within that, and in this case it will be the scaled analog input and the scaled analog input for the other one as well. And that's pretty much it for this simple differential. So that's what that's doing now, is I've got a math function that subtracts the high value and the low value from the high value, and it'll obviously give you then the difference between the two. So if they're both reading exactly the same, it doesn't matter what they're reading, they could both be measuring 10 volts. If they're both measuring the same value, you get an output of 0. In my case, I want to compensate for cables, so I've got a low side and a high side, and it's the difference between them that I'm interested in for the volts. And I've done exactly the same thing for the current, so that's V differential, and I have a current differential here somewhere as well, amps differential, sorry, is what I called it. And you can see here it's got exactly the same function in here, that it's amp differential high scaled value minus amps digital low scaled value. Sorry, I said differential there. Amps digital high value and amps digital low. All right. Now for the amps as well, I've actually set the scale. Let me just zoom back out again. Okay. What I've got here at the bottom is I've got the amps one set to 4 decimal places, and the reason for that is because I'm measuring much lower values, half a volt, and because they're all point something, then I want to maximize the chances of being able to detect those low wattage readings and low current readings. If I go back to the voltage converter, you'll see that I've only got 2 decimal places set for this one. The next thing I've got, so that's the volts and the amps doing the differential measurement, and the problem with the math builder right now, which is what I mentioned with one of the bugs, is that if you try and attach this to a digital display or directly to a an output like a text thing, it will continuously give you 4 decimal places of resolution, and it has a bug in it. It doesn't work very well. So the fix for that is to actually use a string converter, and I'll show you what that is in a moment. But one of the things that you have to do in order to get these function elements up onto a visual element is you have to effectively update the display. So what I have is an if I can find it here. Oh, update display timer. Sorry, couldn't find it there for a second. So I'm using a timer action here on the left-hand side with all the functions. It's just this thing down here. It's just a timer. It's the bottom of the function list, and it creates a timer for triggering actions. And the action we want to do is to update all of these display elements with the values from the function element. So what this one is set for is every quarter of a second, which means all my displays are going to update 4 times a second. I'm calling an action element called update displays. And update displays, the way you configure this, and this is where you can see it looks almost identical to what we were looking at a moment ago for the serial port, where you define a variable and an expression that's going to be set to that variable. And now the variable, the same thing, it can be a variable, it can be a property. In this case I've got a property selected. So what this is doing is every 4 times a second it's assigning the watts display text to the watts converter value. It's then assigning the volts display text, volts display differential text to the volts converter, which we just looked at before, which is calculating the differential voltage. Sorry, I'm getting ahead of myself slightly. Normally, without the bug, you would be having this connecting straight to the differential math function that I just showed you for doing the convert volts or the V differential or the amps differential. But because there's this bug, I've got a string builder which is needed. Now the output of the string builder is this watts converter, volts converter, amps converter string builders that are actually allowing me to set the proper number of decimal places. You would normally, as I say, set these straight to the mathematical functions, which you would see here if you were looking for them. They would show up with these little like stacks. So there's my V differential, and I could put that and just select the value, but unfortunately that one's going to give me a screwed up display. And you can try that if you like, but for now I'm just going to go put it back to the string builder and the value. I'll show you what that is, how you configure that in a moment. So anyway, what this is doing is 4 times a second, it's basically taking all of these expressions and evaluating them and assigning them to my values up on the top, on the left hand side here. So in most cases they're being assigned to properties on the screen. This number 5 one is actually being assigned to a variable, and what this is doing is it's assigning the output of the totalizer, which is what is accumulating the amount of watts that have been used, and we'll have a look at that in a second. And then you've got, so this is actually forcing the totalizer variable to be updated. The last one, which is number 6, is assigning the totalizer variable to a display item. So this one is actually triggering one of the math functions to occur. Now the totalizer, let's go look at that one for the moment. There, totalizer, that's the math function. If you look at what this is doing, what it says is totalizer variable plus open brackets the watts calculated value, so that's our instantaneous watts, and it's dividing it by 14,400. Now that is equivalent to an hour, and because I'm doing 4 samples a second, it's basically 3,600 multiplied by 4, which gives us 14,400. And the reason it's dividing it by that is because we're slowly accumulating the amount of watts, and if I'm actually instantaneously using 20 watts, then the watt hour should be showing after an hour 20 watts as well. So because I'm sampling at 4 times a second, I have to divide it by the equivalent of an hour, which is 14,400 samples, and that allows it to be displayed properly. Now at the bottom here, because that's such a small number, I've set the number of decimal places to 6, so that you will see it accumulating even if you've only got a few milliamps flowing through your load. And as you saw before, that then gets assigned up into the using the every quarter of a second, it's getting updated into the display. Alright, so I haven't shown you, I've explained the totalizer there for a second, but I haven't yet explained to you how this is getting the watts calculated for the power. So that is a simple math function. So what I have here is a watts calculator. That's another one of these math builder functions, and that one, as you can see here, is very simply the volts displayed differential, which is this top left one here, which we got from subtracting the low volts from the high volts to give us this, and we've got the current, which is the low volts taken away from the high volts to give us the actual current. Now here I'm saying whatever this is displaying, multiply it by the current. Alright, so that's just this one multiplied by this one, and that one is being assigned as the watts calculation. And in that little list of actions that we were looking at a minute ago, that was actually being assigned to this display here, which is the watts display. And if we go back and quickly look at the timer update, you'll see the top one, sorry. So you've got the watts display is being assigned to the string builder. Now again, I keep hitting that, so I'm going to show you what the string builder is doing right now, because you're going to be scratching your heads wondering what's going on. So let's just pick the watts converter here, which is what I've called it. What these string builders do is they'll take an element property. So I've actually said the watts calculation, which is the amps differential multiplied by the volts differential. I've taken the watts calc value and I've told it to restrict it to 2 decimal places. That's all I've told it. You can actually do other things, like if you hit infinity or minus infinity or true or false, you can have additional strings, put up in the display if you want. You can change the number of decimal places. You can change the formatting to hexadecimal, natural or scientific format and things, and you can change the case to be lowercase, uppercase, or normal, and things like that. But really the only thing we're using this for right now is to reduce the number of decimal places. But the input to this, you pick an element with its property, which is the calculator, and the output is a dot value, which we've used in the update displays routine to assign it to the actual text display element. So as I said, normally you would use the update display function and have it go directly against the watts calculator, because the watts calculator, as you can see right here, does have another number of decimal places set to it. But there is a bug right now. Again, I'm repeating this, I can't stress it enough at the moment. Beta software, and it's one of the acknowledged bugs, that it doesn't do this number of decimal places properly and relay them up to the display. So you've got to compensate by pushing it through the string builder, and that fixes your problems. Now let's look at the math builder again for a second, because one of the things I want to show you, I'm actually just going to pop another one up on the screen so I don't mess up any of my existing ones. Where is it? Math builder. All right, I'm going to delete this before I do anything. So when you go in here, you can see here these functions you've got. You've got all the basic stuff, like you've got addition, you've got subtraction, you've got multiplication and division, but you've also got things like modulus. You've got punctuation, so you can add dots in the in your output and things. You've got your parentheses so that you can force priority on your evaluation. You've got bitwise AND, so if you're reading in and you want to do some bitwise manipulation on a value that came in potentially from the serial port, or if you're trying to do something, I don't know why you would do it with an analog input, but you might. These math functions can work against any property, of course, so it doesn't have to be just analog ones. Anyway, you've got bitwise OR operators, you've got a NOT operator, you've got an XOR operator, you've got shift left, you've got shift right, you've got a ternary operator, and you've got a for continual. I don't really know much about those ones yet because I haven't played with them. But anyway, so you've got quite a few functions here that you can apply. Now, if I just put something in here, if you look at the value, all right, you can see here you've got exponentials, you've got log, pi, root, square roots, random number generator, infinity. So you've got quite a few different things that would allow you. So if you were trying to generate maybe a value for showing dBs, for example, or you were trying to well, basically, just doing some calculating a diameter or something like that, because maybe one of the analog inputs was reading a distance in millimeters or something like that, and you wanted to calculate a circumference from something. You could easily do that because now you've got all the pi functions and everything else as well. All right, you've got functions in here, so you've got the sine, cosine, tangents, floor, logarithmics, min-max, rounding, sine, square root, tans. So they've actually added quite a few mathematical functions that allows you to build up some quite complex mathematical operations. And because you've got the brackets and things like that as well, you can build up in here. I haven't tried to see how far it will go, but you can build up quite a complex mathematical function to do whatever you want. And that can be then reflected as an output. It can be reflected on the display. You could use it as a part of a decision tree using the logic builder, etc. So anyway, that's the math function. I recommend that you download the software and play with it. Like I said in previous videos, you do not need the hardware. You can actually run this without any hardware being connected in an emulator, and it will allow you to try out all the functionality without buying the hardware. And then so you can easily now try out all this math functionality as well. So what else have I got to show here? Oh yeah, the clock. All right. So I've shown you how I've done the accumulator by adding the watts to the accumulator plus the accumulator. The elapsed time is an interesting one because it doesn't actually have a digital timer in here, and it also does not have a built-in mechanism for you know, I've done a power meter and I wanted to show the ability to say what are the watt hours accumulated so far, and really to go with that you really want to have a counter as well. So I've put one in and I had to build that up in stages. So what I've got is I've set a project variable called accumulator time, and all it is an integer. All right, and what I've done is I've set a timer as well, which is somewhere here, elapsed timer, and I've just said every 1 second call an action element elapsed timer actions. All right, and if I go to elapsed timer actions, you'll see it's got 4 things in here, and if I look at this, we'll see you've got the accumulated time equals, and then it's calling a math function which is increment elapsed time. It's then also saying update accumulated hours text with a string builder. Now as you remember, that's because of a bug, and what it's really doing is going after the hours mathematical function. We're updating the accumulated minutes and accumulated seconds, and again it really would normally go after the math functions, but in this case we've gone after the string builder because of this bug. And if I look at the string builder for those, all right, there's nothing special about them. It's just saying, sorry, let me just go to the right one. Convert seconds is just taking the seconds, and it's just saying I want an integer with no decimal places. The minutes is the same, and the hours is the same. Now, I've got the math function for hours, though. Let's start with seconds, actually. It's just accumulated time modulus, remember the percent sign is for mod, 60. So what that's doing is basically taking any seconds up to 60 and it's throwing away everything else after that, above that, and it's leaving you just the 0 to 60 seconds or 0 to 59 as a counter. And then the hours is very similar. Sorry, going the wrong way. Calc hours is doing accumulated time divided by 3600, all right, for calc hours, which is fine because I'm not trying to do days or anything else, so that's just going to be the hours. And then the calc minutes is actually a little more interesting, but still very, very basic, in that I've got the accumulated time divided by 60 because I'm doing minutes, so I've got rid of the seconds because accumulated time is in seconds. And then because I've divided by 60, I've now got minutes, but because I have another hours counter as well, I don't want to show the overflow beyond 60 minutes. So I'm doing a mod 60 to make sure it's only 0 to 59. And then all of those, as you saw, are linked in by the converter, where it takes the calc hours, make sure there's no decimal places, and then the elapsed timer actions is assigning those to the variables. And what I've got is an hours, minutes, and seconds display windows here to be able to show the accumulated, basically the accumulated time. The last thing that I've got in here is this reset button. So that's actually a button object on the display here. Where is it? Reset Totalizer is what I've called it. No, reset button, sorry. And the reset button, when you put any button in the elements, you have to assign it a visual element to work with. So what I've said is it's ellipse. I haven't bothered renaming the ellipse, which is this circle here, from its default name when I loaded it on the screen. And what I've said is the on-click action is call a function called reset totalizer. So right here is my little action function, and if I look at what that does, it just basically says the totalizer variable, which is the one that's incremented with the power, just set it to 0. and then immediately also set the accumulated time, which is being incremented by 1 every second, set that to 0. So what that allows you to do is simply reset the accumulated power and the timer, and so you can do a under user control a timed event. I guess what would be nice in here is probably to add a start and stop button or something like that, but for now I think this will be fine for the demonstration purposes. Anyway, I think that's pretty much it. So I'm actually pleased that Lascar have released this extra piece of software. The maths functionality I think is awesome that they've added that, and it allows a lot more powerful functionality to be built into the panel meter. I'm a little disappointed with the serial comms, not because they've enabled the serial port, which has been part of the panel meter, but because why have a serial port in this day and age anyway? You've got USB, and it would have been far more useful to have the comms coming out of the USB port. It's already there. When you look at your computer, when you have this thing plugged into it, it shows you that you've got a USB port connected to the panel meter, and you know, to be able to send it out of there to connect to any modern PC would have been just awesome, because then you've got full data logging capability and everything. My concern right now is just who has a serial port? I don't. And unless you've got a legacy computer, like, I mean, a really legacy computer, you won't have one. Most laptops and PCs that you buy, I doubt you could go into any standard store now and buy a PC with a serial port. You have to go buy special adapters to add that functionality into it. So, you know, from my perspective, why? It just seems lame to even have it there. You know, and I can understand why you might put it there, but, you know, this is the first release of software after the initial release of the panel meter. So I don't want to come down too hard on them, but from a priority perspective, Lascar, what are you thinking? Get it going through the USB port. Add the regular RS232 serial port, sure, but the USB would make this thing so much more attractive to everybody. Anyway, I think that the beta software is definitely worth a look. You can go to lascar.com, download it, or panelpilot.com and download it from there, and have a play with it. Like I said, you do not need the actual panel meter to run this, which reminds me, I was going to show you that. When you're running the software, if you just simply hit F5, you've now got a new design output. I'll show you the old one. This is exactly the same as what the old meter used to be, the old software before the upgrade was. And you know, I've set my analog inputs here to 30 volts and half a volt. You can just adjust these sliders, and you can see here that the differential input is working quite nicely, like that, calculating. And as I say, it's updating 4 times a second. There's my current. So if I set that to 200 millivolts there, and I take this one and set it to 100 millivolts roughly, you'll see that it's doing the automatic calculation. I've just got 1 amp, even though I've got 2 here and 1 here. My volts is working nicely. My watts is now calculating quite correctly. Little over 3 volts at a little over 1 amp, and it's giving me 3.33 watts. The kilowatt hour is now calculating correctly, and of course it's not deviating because these are all static values. And now I'm accumulating the power here as it should be, and my counter is slowly counting up hours, minutes, and seconds. And I haven't yet figured out how to have a leading 0 on the display here. I'm sure there's a way to do it, but haven't figured it yet. And one of the things that you also notice now that they've got the RS232 working is up on the left hand side here, it's actually showing you the output that it's sending through the RS232 port. Now I showed you that actually going out on the oscilloscope. This in the demo mode is showing you the values coming out in a little table here. And you can see if I just tweak these values, you can see they're automatically being changed because I'm outputting once a second on the serial port as well. And the accumulator is going up there nicely. If I just whap this up to the max, you'll see it's probably going to accumulate quite quickly now. So the accumulator is not outputting. Oh, that's the time, accumulated time. Sorry, it's because it's shrunk the display here. It's not showing me Yeah, accumulated time. I was looking at the wrong one. So that's saying 2 minutes and 22. This is just showing it in seconds. Thought there was something wrong with my accumulated watts there for a moment, but that's the one above it, 1.5 there. And then this is the instantaneous watts that we have, 135 watts. So that would be quite a lot. If this was actually running a power supply, by the way, and you set up a current and a voltage that was more than the power supply could handle, you could actually have an alarm on here that would set and actually turn the output off through a relay or something like that to actually prevent you from overloading the power supply. But anyway, I think that shows you quite nicely the functionality. And as I say, this is the original display. The only other one I want to show you right now before we finish this is the new design, and they've laid it out slightly differently, and it's messed up because of the way I've got this display. It's off the screen, but anyway, what they've done now with the new display is they have them all as individual panel elements. I'm just moving them onto the screen because I've got 3 screens running here, and I've just rearranged it and it's messed it up. So you've got all the alarm outputs and the other elements as separate pop-ups. So there's my analog channels and there's my PWM outputs here. And you can do pretty much the same thing. It's just a different layout for the same functionality, all right? So that's pretty good. You can zoom the screen, of course, it says here, so make it much bigger for looking at it. All right. Let's bring that back down again. Anyway, download the software, have a play, and if you've actually got one of the panel meters, I highly recommend upgrading the software, especially to play with right now. To have a look at this new mathematical functionality. If you do, if you are fortunate enough to have an RS232 port, then go right ahead and hook it up and see the output. I will post the project that I did here onto my website or something like that, so that you can get a hold of it, or up onto GitHub, so that you can download it yourself and have a play with it and tweak it to your own liking. Anyway, I'd like to thank Radio Spares for sending me the PanelPilotAce and the prototyping, evaluation kit, so that I could bring these videos to you. And yeah, next video, what we're going to do is maybe enhance upon this and have some relay. I'm going to show you how to drive some relays and various other things using the output alarm and digital outputs, and also respond to maybe some push button inputs, and use maybe the alarm outputs as well as the PWM outputs to drive some power LEDs or something like that through it. It's only 256-bit, unfortunately, so it will be a little bit limited in its resolution. And one of the things I'm actually hoping for, and if Lascar are listening, is that they will bring out the capability of using either the SPI or the I2C bus, which is also included on the back of the panel meter, so that I can hook up an actual external D to A converter, so that I can have some true analog outputs being driven for my projects, because this would make a very good controller for my power supply. Also, Lascar, if you're listening, the ability to have a little numeric keypad pop up maybe on an event, if you wanted to type in an alarm setting and you just want to be able to hit a button, bring up a little touchpad so that you can type in a numeric value with an enter key and stuff like that, would be really awesome. So yeah, anyway, I hope you like it, and we'll see you soon.